Hi everyone, welcome to my YouTube channel. Today we will be discussing about the last part of finite square wave potential, which is scattering states. We know that the energy has to be greater than the potential either at plus or minus infinity to represent a scattering state. Here the potential is minus V naught for a small region minus A to A and 0 everywhere. So to represent a scattering state, the energy has to be greater than 0. For the region left side of the point minus A, the potential is 0. If we use the 1D time independent Schrodinger equation, there we get minus h car square by 2m d2 psi by dx square equals to E psi. That means d2 psi by dx square is minus 2me by h car square into psi. Here I am writing k equals to root over 2me by h car, where k is a positive constant. So the solution of this equation becomes psi equals to a to the power ikx plus b to the power minus ikx. Now for the region minus a to a, the potential is minus v naught. If we use the Schrodinger equation in 1D, we get minus h car square by 2m d2 psi by dx square minus v naught psi equals to E psi, or d2 psi by dx square equals to minus 2m into E plus v naught by h car square into psi. And I am writing L equals to root over 2m E plus v naught by h cut. So the solution of this equation becomes psi equals to c sin lx plus d cos lx. For the region x greater than a, the potential is 0. So the Schrodinger equation becomes minus h cut square by 2m d2 psi by dx square equals to E psi, or psi equals to e to the power and the solution is similar to the first case, and the solution is similar like the first case, which is psi equals to f e to the power ikx plus g e to the power minus ikx. Now if we consider that the particle is coming from the left, so it will be reflected by the potential. So we can get a reflected wave and we can get a transmitted wave. We cannot get a wave which is coming from the right hand side. That's why we are taking g equals to 0 and psi equals to f e to the power ikx. So our solution becomes f e to the power ikx for the region x greater than a, c sin lx plus d cos lx for the region minus a to a, and a to the power ikx plus b to the power minus ikx for the region x less than minus a. Here a is incident amplitude, b is the reflected amplitude, and f is the transmitted amplitude. Continuity of psi x at x equals to minus a gives, we just have to put x equals to minus a in this equation, this sin cos and AB equation. We get the equation 5, and here the potential is finite, so the continuity of the first derivative of psi at x equals to minus a gives equation 6. We just have to derivate this psi and put x equals to minus a, and we can get equation 6. Similarly, the continuity of psi at x equals to a gives equation 7, and continuity of d psi by dx at x equals to minus a gives equation 8. Now let's multiply equation 7 by sin LA and equation 8 by cos LA by L and add them. So we get these two equations after multiplying, and if we add, the second term cancels out and we get c equals to f e to the power I k x into sin LA plus I k by L cos LA. Now similarly, if we multiply equation 7 by cos LA and equation 8 by sin LA by L, and if we subtract them, we get D. So if we multiply them, we get these two equations, and if we subtract them, the first term cancels out and we can get D equals to this equation 10. Now if we use equation 9 and 10, that is the value of C and D in equation 5, we get equation 5 by using the continuity of psi at x equals to minus a. So if we put the values of C and D in that equation, we get equation 11 after simplifying. This is very simple. You can see the screen how to simplify it. Then again, if we use equation 9 and 10, that is the value of C and D in equation 6. What is equation 6? The equation we have got after using the continuity of the first derivative of psi at x equals to minus a. We get equation 12. Just put the value of C and D and do some algebraic simplification. You can see the screen how I have simplified the equation. It is crystal clear. You can get equation 12, and now we can add equation 11 and 12. This is equation 11, and the left hand side of equation 11 is this term, and this is equation 12. So if we add them, we get 2a to the power minus ik in the left hand side and this term in the right hand side. Again, after simplification, we get f to the power ik 2 cos 2la minus I sin 2la into k square plus l square by kl. Now we want to derive an expression for f in terms of a. So just take the coefficient of f in the right hand side of the equation to the left hand side of the equation, and we get this equation 13 after simplification. This is very simple. Just take 2 common from the denominator and cancel from the numerator. You get this equation 13. Now subtract equation 12 from 11. So this is equation 12. If we subtract this equation from equation 11, this equation, we can have 2b to the power ik in the left hand side and this in the right hand side, this part in the right hand side. And similarly here we are trying to derive an expression for b in terms of f. So from here we can see that cos 2la will cancel out and we get this equation 14 very easily. Now we know that transmission coefficient is f mod square by a mod square, where f is the amplitude of transmitted wave and a is the amplitude of the incident wave. So let us derive an expression for T inverse, because if we try to derive the expression for T, it will be very complex calculation. So to avoid the complexity, we are trying to derive the expression for T inverse here. We know T inverse is a mod square by f mod square. So from equation 13 we have equation of f in terms of a. So from here we can see that a by f equals to cos 2la minus I into k square plus l square by 2kl into sin 2la by e to the power minus 2ik. I have just written that here in the first part. we know how to square a complex number. That is, if z is a complex number, so z square is nothing but z into z star, where z star is the complex conjugate of z. I am just doing that here. So a by f is this first part, so we have a by f square, and from here we can see that a by f is a complex number, so just multiply with the complex conjugate with it. So the complex conjugate will be cos 2la plus I into k square plus l square by 2kl into sin 2la by e to the power 2ik. So the denominator cancels out, and from the numerator we get cos square 2la plus k square plus l square whole square by 4k square l square into sin square 2la. We know that cos square theta is 1 minus sin square theta. We have just used that trigonometric identity here. So cos square 2la is written as 1 minus sin square 2la, and this part remains same. And now I am taking sin square common from the last two part of the equation, and we get k square a plus l square whole square by 4 k square l square minus 1. So from here, if we take LCM as 4 k square l square and subtract this, we get k square plus l square whole square minus 4 k square l square. But there is a very simple but important algebraic identity, which is a plus b whole square minus 4ab is equals to a minus b whole square. I have just used that identity here. So you can imagine k square as a, l square as b. So you can get from this equation as k square minus l square whole square, the numerator part, and the denominator part remains same, and sin square 2la remains as it is. Now we know that L is root over 2m e plus v naught by h car. So La is a by h car into root over 2m e plus v naught, and we know the values of k and L. Just put here in this equation k square minus l square, and we get minus 2m v naught by h car square. So k square minus l square whole square by 4k l square is 1 by 4, the constant. Then we know k square is 2me by h car square, so 1 by k square is h car square by 2me, and 1 by l square is h car square by 2m e plus v naught, and we have just derived the expression for k square minus l square whole square, which is 4m square v naught square by h car to the power 4. Then just after simplifying, we get v naught square by 4e into e plus v naught. Now using all these values in T inverse equation here, so we have derived the expression for this constant or coefficient, and we know what is La. Just put those and we can get T inverse as 1 plus v naught square by 4 e into e plus v naught sin square 2a by h car root over 2m e plus v naught. Notice that if the sign part of this equation is 0, then we can get the T as 1, that is, the particle will pass through the barrier completely. So we know that sin n pi is 0, so 2a by h car root over 2m e plus v naught is n pi, where n is any integer. So from this we can get e plus v naught equals to n square pi square h car square by 2m into 2a whole square. The RHS of equation 16 are the allowed energies for infinite square well of length 2a. This is a curve of transmission coefficient with respect to energy. From here we can see that T approaches 1 as the energy increases, and which is also sounds reasonable, because if we increase the energy, the probability for transmission from the barrier increases. That's all for today. Thank you for watching this video. If you like it, please subscribe, like and share. See you in the next lecture.